Okay, number 5, we'll go to the whiteboard to do it. Let's do the first step, it's writing it down. And this is number 5 again. What do I see there? Certainly an integration problem. And then I see this over here. So the integrand looks kind of complicated, but it's following the general pattern that we've expected to see at this point. So you make a substitution. I'll tell you what the substitution is going to be. It's going to be x equals, let's see, the root of 7 times the sine of theta. Dx would equal root 7 cosine theta d theta. Let's pop it in, see what we end up with. Certainly hit a 1 there. X squared would be 7 sine squared. All right, let's keep going. Let's put the root down now. The root would be 7 minus 7 sine squared of theta. What's dx? Root 7 cosine theta d theta. Got to simplify that as much as I possibly can. Let's see what we get over here. Well, a couple of things I see immediately. I can look at the numbers first. And, if I factor 7 out here, it's root 7. So I'm seeing some cancellations. And, I get like 1/7. That's not so bad. The next thing I'm looking at, I'm definitely seeing a cosine theta on top. I'm seeing a sine squared theta on the bottom. And that root, remember, I factored the 7 out, so it's 1 minus sine squared. 1 minus sine squared is cosine squared. And on this invertible region, I don't have to worry about the absolute value, so it just could be cosine of theta. This conditionally cancels off. And what have we left off? 1/7 of a, let's see, 1 over sine squared. Oh, that's going to be cosecant. All right, and I realize a lot of times you can't remember, and I can't either sometimes. And I want to just say, it looks sort of recognizable. And I'm going to say I'm going to make a stab at it. So I'm going to say, I think the antiderivative of this guy over here is minus cotangent. But I still want to check myself. So I'm going to say minus 1/7 cotangent of theta plus some constant of integration. So you really want to do it, I was going to say, I wonder if I'm right. I wonder if I made a mistake or I can't remember. So I would differentiate d theta, the cotangent. What's cotangent? The cotangent is going to be cosine theta over sine theta. Let me differentiate that. I'm going to erase that if I do it, by the way. I just want to check if I'm right. So you get sine squared theta. And then what do you get? You get sine times minus sine, which is minus sine squared, minus cosine times cosine, which is cosine squared. That gives me minus 1 over sine squared. Let's see, that's going to be minus cosecant squared. Yeah, so it's good. All right, we're good now. All right, so what are you going to do now? Well, I need to go back, and that's the problem. I need to go back. Where do I need to go back to? Well, I need to go back to this substitution. X was root 7 sine theta. What does that mean? X over root 7 sine theta. Let's do a little diagram, not diagram, but a triangle. Theta. Sine is going to be opposite. This will be root 7. Pythagorean theorem, that would be 7 minus x squared. All right, what do you got to do over here? Gee, the cotangent, right? Minus 1/7. The cotangent is going to be the root of 7 minus x squared over x plus c. I'm done now. I'm going to simplify a tiny little bit. I'm going to say minus, and bottom is 7x plus c. Going to commit to this answer. Again, sometimes when you look at an answer key, you wonder, am I right or not? And I'm going to look at the key now. And I'm looking at the key that's provided to you. This is good, that's good, and that's good. It's time to go to the next question. Thank you.